Okay guys, in this video we're going to be doing linear equalities. We have solved these before, but we have graphed them in one dimension, but we have not graphed them in two dimension yet, and we're going to do that today. We know these are in two dimension because they have an x and a y in the original equation. So we're going to look how to do this. So I just told you the y. They're in two dimension because they have two variables because it's a two-dimensional graph. Two variables equals a two-dimensional graph. Or we'll just call it 2D graph. Okay? The graphs of the linear inequalities involve, so if it's a two-dimensional graph, that means you're going to put it on an xy plane. Okay? When we only had one variable, like x is less than 3, if you remember, we would plot, show where 0 was, and then 3, we'd put an open circle there. Everybody remember why? That's right. Remember, there's no equal sign, so we leave it open, and it's less than, so we would plot that to the left. So we're going to use some of those same concepts to do this. The graphs of linear inequalities involve a boundary line, okay, which your boundary line is your y equals mx plus b that you come up with. Okay, and it's also going to have a region. It's going to have a solution region. Sorry. Which you're going to show that region by shading. Okay? Now, remember what you must do if you multiply or divide both sides by inequality or a negative number? Remember before, if we had negative 2x is less than or equal to 8. If you remember, if we divided by negative, remember it changes both of these signs, so it also changes the inequality. So this would actually be x is greater than or equal to negative 4. So it's going to be the same thing here when we divide by negative. All right, to graph the line, we're going to use the slope and the y-intercept. You saw the lines for, so solid would be like if you had a closed dot. So if you remember, that's when you have an equal sign. So you have a less than or equal to or a greater than or equal to. Use dotted lines when you have like an open circle. And remember, that's when you don't have the equal sign. Okay? All right. So if we look at this one over here, you'll notice in this example they started with something that looked like standard form, and they changed it to y equals. They chunked the 4x over, and then so they got negative 4x plus 10, and then they came back and divided everything by negative 2. Now, remember here, when you divide by the negative, it switched the inequality, okay? Negative divided by negative is a positive, so 4 divided by 2 is 2, and then 10 divided by negative 2 is negative 5. So you ended up with that nice, pretty slope-intercept form. So let's go back. Let me get rid of that, sorry. So let's go back and remember how to graph. We start at negative 5, so the graph starts down here. Let me move that down a little bit. The graph starts down here at negative 5, and then it goes up 2 over 1, up 2 over 1, up 2 over 1. Now, why is this line dotted? Because there's not an equal sign. Now, what we're missing here is some shading. Whenever you have inequality, that means, because the line just means equals all this, right? Okay? But we need some shading here because we shaded up here. Remember, we had the little inequality on the number line. We're going to shade on our graph. Now, y is greater than. That means we want all the points that are greater than this line. Well, greater means bigger, right? So greater means up. So we're going to shade above that line. So shade that in. If this was a less than sign, then we would shade down here. Okay? All right. I'll move this down a little bit more. So that's how you tell just by the inequality. You can also see where it says pick a side and select a point on one side of the line to test by plugging it into the original equation. The best point to use is 0, 0 because that's easy to plug in. So if we plug in 0, 0 here, I would plug in 0 is greater than 2 times 0 minus 5, right? Well, when I work all that out, I get 0 is greater than, 2 times 0 is just plain old 0. 0 minus 5 is negative 5. Is 0 greater than negative 5? Yes. So what that means is that the point 0, 0 is a solution. You will get a true statement. So that means that it is part of the solution set. So I'm going to shade 0, 0. But actually, if I chose any of these points, I could have chosen 1, 2. If I plugged in 1, 2 and worked it out, I would have gotten a true statement. If I had plugged in negative 3, 0, I plugged that in, I would have gotten a true statement. So any of these points on this side of the line are solutions to this line. These points down here, if I plug one of those in, they will not work. If we do one real quick, we use 4, 0. Let's try this one. 2 times 4 is 8, minus 5 is 3. 8 minus 5 is 3. Is 0 greater than 3? No. So that gives me a false statement. So that means that one's not in the solution. Okay? All right. All right. So if the final statement is true, then you shade that region. Or you're gonna, let's just put shade. Okay? You're going to shade that point, which will shade that whole region. If the final statement is false, you're going to shade the other side, or the other region on the other side of the line. All right, let me turn my phone on. Okay, so on the next one, we're going to graph it a little bit quicker. Luckily, A is already in slope-intercept form, so we can just go ahead and get moving. I'm going to make my slope over 1, so I'm going to graph it. So I'm going to put plus 3 here, okay, because that's where I'm going to begin. And then I'm going to do my slope, down 2 over 1. So I go down 2, right 1, down 2, right 1. Or I can go up 2, left 1, as long as I'm going negative, okay, on one of the turns. All right, I'm going to graph that line. And before I graph this through, because we're used to just graphing those lines in, we got to make a decision, okay? Our decision is go up here and look at our inequality. Does it have an equal sign or not? This one does. So that means that we're going to draw on the line. So I draw the line in. Okay. So what that means is, since now this line is included of a solid line, that means that not only will we have points in a shaded region that are a solution, but also any of these points on the line will also plug in and be a solution. And we'll talk about that more in class. But now if we plug in 0, 0 real quick, if we do 0 is less than or equal to negative 2 times 0 plus 3, that'll tell us if the origin is a solution or not. So we work this out. 0 is less than or equal to negative 2 times 0 is 0 plus 3. Is 0 less than or equal to 3? Sure it is. So that means that 0, 0 is a solution. Check. So that means we're going to shade this side of the line. If this came out to be false, we'd shade the other side. Okay? But also remember, I said, if the sign, as long as you have this in slope-intercept form, that's key. It must be in slope-intercept form. Y equals. If this sign is less than, then it's going to be everything below that line. And that happens to be the same region as the 0, 0. Okay? All right. On this one, we need to change it to slope-intercept real quickly. So we're going to chunk the x. Okay? So we get negative 3y is greater than, the 2x comes over, it becomes negative, and then we have plus 6. Let's see if I can move this over a little bit. There we go. All right, so we get plus 6. All right, so I'm not done yet. I got to divide. Well, unfortunately, I have to divide by negative 3, don't I? I'm dividing everything by negative 3. So remember, that negative means that I'm not only going to change all the signs, but I'm also going to flip this inequality. So it's actually y is less than, the negatives cancel here, 2/3 x minus 2. Right? So let's graph it. Start with your y-intercept. So we're going to start at negative 2. Our slope is positive 2/3. So that means we're going to go up 2, right 3, up 2, right 3, up 2, right 3. Now, I got to stop and make a decision. Don't just draw your line through, okay? We got to make a decision. Is it going to be open, or excuse me, is it going to be dotted or solid? There's no equal sign here. So that means that point is not included, or that line is not included. So we're going to show that by dotting it. Uh-oh, I got off. Sorry. Let's try again. Use your straight edge at home, okay? Make it look nice and pretty. Now, our sign shows that we are doing less than, so it should be down here, okay? Let's check it using our origin. Now, hopefully, our origin gives us a false statement because it's not in the shading. So if I plug in the origin, that would be 2 times 0 minus 3 times 0 is greater than 6. 2 times 0 is 0. 3 times 0 is 0. Is 0 greater than 6? No, that is not true. So that's why your 0, 0 is not in the shading. Okay, hope that helped. We'll work on the rest of it in class.